In this set of slides, I'm going to be talking about how to interact with files using your Python program. Talk about two different functions, reading files, writing files, and also formatting outputs. And this is really working with strings, which is going to be the format that you write two files in and that you read from files. A little bit of sample code just to start us out, 5 lines of code. Importing a library called OS, operating system here. A variable called working directory is set to equal a string, kind of recognizable as a drive and a folder in a directory, but with this R before the string. We haven't really seen that before. Another variable called directory list is going to be the output of the list_dir method, list directory method, in the OS library. And the argument that's going to be passed here is working directory for that string, and then a for loop. So for each looping variable in that list, the output of the list directory, print it. So this is a short little bit of script to look in a directory location to see what kind of files are in there and to print them out one at a time. Working with files is very important. It allows us to get input data. So these for shapefiles could be geometries, the points. They could be the values in the attribute table. Could be the spatial reference information, the PRJ files. Working with files, we can write output to these files. We can, or results from our analysis. Python does indeed treat reading and writing as separate tasks. And another task we'll learn about is closing. And this is kind of, think of this as cleaning up the garbage, really the memory space in the session. We're going to be, especially working with shapefiles, using quite a few strings to represent locations on the computer. And so there are two ways to do that. Briefly, we talked about how using double backslashes allows the interpreter to detect a single backslash, which is kind of what you want. The other way to write a string and to have these backslashes maintained rather than used to signify an escape character is to put an R in front of the string, just a lowercase r. Still a string object, but it's telling the interpreter, do not read this backslash as part of a new line or a tab or an escape character. So here's kind of a basic setup for some reading and writing of files. So we have the str path, the string path, folder resources on the Y drive, and then the string name, the specific name of the file. Note that all backslashes, marking a kind of hierarchical relationship, folder within a folder or a folder on a drive, is within the string path. So one way to put those together is simply using the plus sign. This is a expression here. A string plus a string is just the first string plus or added on to the right side of the first string, the characters in the second string, and that's the string path name. So here we see the open function where we're passing two arguments. One is the string path name, the name of the file and its location as a single string, a comma separating that argument from the next, which is just in quotes the letter R. This signifies read mode. And then that F is the object. That's a variable name. F is going to be the file object open within the script. So this string path above might be written using forward slashes. Those would work in the sense that it wouldn't get reduced to escape character. You can use the letter R as up here, or you can double up on the backslashes. And what that means is that that string will be read as having only a single backslash here. So specifying the directory is an important process. Kind of the earlier examples we just saw in this slide. Create the complete file path. So this is the file name, and that's going to be the second operator in the addition, the file directory, the first. We can use the plus sign to concatenate those strings, but when we do, we need to be careful of one potentially pretty common mistake. In this kind of example here, these 3 lines showcase the mistake. Directory name on the D drive, Intro to Python, fall 2017, and it does have the double backslashes here, so those are not going to get reduced out. File name looks fine, but what's going to be the file path variable? There's going to be some error. And the error comes from our failure to have backslashes at the end of that string. And if we lack them, what the file path will be located in one folder up in the directory from where we would like to look, and it's going to be looking for a text file with a name that probably doesn't exist. Not test.txt, but files test. So if you have a directory up here, always remember to to end that string with the double backslash or a single backslash if you had the letter R in front, say. So you're not necessarily so the other solution here, where you don't finish that directory string with a backslash or a double backslash, is not to use the plus sign to put those 2 strings together, but rather to use the join method in the os.path library. So here the working directory is on the Y drive, resources folder, data folder, example folder. The file is example file.txt. If you put these together, if you concatenate them, not with the plus sign in an operation, but with this join method, you do not need trailing backslash. The join method will insert that automatically. Other methods from the os.path is the exists method. Takes one parameter, the path. It returns true if the path exists, false if it. So this might be a good way to check if the file that you're looking for, if you want to read from it or make changes to it, really does exist in the place you're looking for. You can run the get size method to see how large that file is. You could use this isFile method, which is similar to exists, returns true if the path is an existing file. And then split. The split kind of works as the opposite of join. It splits the path into a pair, where the second part is the last path segment. So whatever is to the right of the final slash or backslash, and then whatever is to the left. So the first function for working with files Uh, besides the open function, which just creates that file object, is the read method. So here we've got a folder path, a specific file, join those together to get a full path. And then within the Python session, we have a variable called f2 here. We can open that file in read-only mode. So we won't change anything though, but we can take information in that file located in this folder and read it into our script. So our program could do other things to it later. Next line, there's a variable called str. It's assigned the output of this read method that we're calling on F2, the file object, and we don't need to provide any argument. It'll just read the whole file. And so that str will be a string object that can be printed. And so if it was a short two-liner, Clark University is in Worcester, Worcester is in Massachusetts. That could be the output printed from this line. Now we can pass an argument, an integer here to the read method. And what that does is it limits the number of characters that are read. So we can have, again, a directory location, a folder, a file, join those two together to get a full path, open that file as a file object in read mode called f2. And then string one could be f2.read 5. And what that means is read only the first 5 characters from f2 and assign those to this str1 variable. And then on the next line, the dot read method is called again, but with no number, and that's assigned to string 2. The file's closed, and both of those are printed. The first string is CLRK, so it's the first 5 characters of whatever was in that file. Now the second is the rest. So it doesn't start over. Kind of once you create a file object called f2 and you begin to read a certain number of characters, if you call the read method here again, it's going to start on the 6th character. It doesn't go back to the beginning. You need to create a new object for that, reset it. So imagine here, we have a text file that when you open it up in Notepad, say, the first line is here is line 1, period. Line 2 is 29 characters long. There are no characters on line 3. Here is line 4. Line 5 has a tab in front, 5 tab spaces at the beginning. So what Python is reading is, here is line 1, so those characters are all the same, but then a \n for the return, a new line. Line 2 is 29 characters long, \n. So line 3, which doesn't have any text, still has that new line escape characters here. Here is line 4, and then the other way that backslashes work into syntax with a T, mark a tab. And note that at the end of line 5, unlike the first 4, here there's no \n. There could be, but if there's no line 6 in the input, there won't. So the one other kind of similar to the dot read method is this dot read line method. Simply reads the first line up until one of those characters, up to and including, I should say. And then the second line can be read if you call read line again. And you don't need to put in a 1 or 2. As I say, when the first line is read, this file object is being read on a continuous basis. The next time you call it in just the subsequent line, It does not reset. Here, this is the first line being read. That's the second. A third reading method we can call on that final object is read lines. So that's just what we see up here, but with an S there. Follow it with the parentheses, but we don't need any argument inside. If we do that, what you get are not output strings, but they're an output list of strings. So we have, this is a list of 2 items. One, the first line string, and second. Only the first has this escape character. So back to file objects. So here we have a folder, directory location, file, and join those together to get the full path. Error on the slide there, I'm sorry. F is a file object. You can open the file at this location, and then the second, there we go. The second parameter here that you pass, and note there is a parenthesis after, is not a lowercase r string, it's a lowercase w for writing mode. Now for the R, if you're reading a file, some file of this name has to actually exist at this location or you'll get an error. For writing mode, a file can be overwritten if it exists, so be careful about that. But the other thing is that you won't get an error if the file doesn't exist. Instead, a new file will be created called readme text in this. So here, if you have the error kind of where you did or didn't include those extra slashes, and then kind of the error could come about if you didn't use this join method, but rather just the plus operator. If you did that, you could be creating a file with a different name than what this string contains in a location different from that file. So your file might be called files readme.txt, and it might be located in the fall 2012 folder. So that's, again, it's not a syntax error, not a runtime error, but it would be a semantic error. Something where your code is running and it can finish its execution, but the result is not what you anticipated, not what you want. So here, if we wanted to rewrite over README, we could write f.write. So on the file object, call the write method and pass the argument string AUM is in Montgomery, period, \n for a new line. You could call the write method again. Montgomery is in Alabama. So we're just rewriting that information about Clark and Worcester, Massachusetts, and then close. And so if you looked in the README text, no matter what had been in there before, if it did exist, these 2 lines are what you'd see. So we'll skip these. So this code here defines a function called copy file, takes 2 parameters, the old file, the new file. F1, that file object, is going to be the existing old file, open that in read mode. F2 is going to be a new file, open that in write mode. Then a variable called text is going to be F1, so the old file, dot read 50. So 50, the first 50 characters are going to be read. That's text. So then while, so this is a while loop, we're going to assess whether or not this condition is true when deciding whether or not to execute those lines. While text does not equal nothing, so as long as there are characters to read in these 50, write to F2 what text is, and then change the value of text to be the next 50 characters in the old file. And that'll go until there's nothing left to read. This condition will no longer be true, and the flow of execution will jump down here where the old file is closed and the new file is closed. A little bit more here today in this video on formatting output. So only strings can be written into a file, even if you want to write numbers. They're going to be the alphanumerical character, a 1, a 2, so on. But you need to convert those to strings prior to writing. So here's just a question. You open test.txt in write mode, could be a new file on your C drive. Write the string for 12.3, that float number. So it's just going to be quote 1, 2, period 3. So a string with 4 characters, number, number, punctuation, number. And then you can also write the string converted list. And that's going to be 1, 2, 3, 4, 5, 6, 7 characters. Another thing about formatting, and note this is just for Python early, Python 2, say it works in Python 2. It's a method of substituting in values to different positions in a string using this format operator. So it's a percent sign, not the modulus operator. It's always going to be within a string. And so you can have a percent %d, percent %f, percent %s. So for inserting strings within a string, inserting floating point numbers within a string, so anything with a decimal point, or for inserting integers or digits into a string. Think of this as substituting in values at the location where you encounter these little tokens. Some examples. So the variable name is assigned the string good. You type out a string here in another line. This is all a string, and that is space %s. And that's within the body of the string. That string is followed by a space, a percent sign, and then this variable, name. What goes in? Good. Students equals 18, 18 students. Here we go. Print, we have %d cars today, and then that string is followed by a %14. That 14 will get inserted at the location of this %d. We have 14 cars today. You can have 2 of these in your string, then just follow it with a percent and a 2-item tuple, where the first indexed position will go to the first encountered, or the 0th index 14 here will go to the leftmost %d. You can have 3 %d, %s, %d, and so on. Or you can have your string consist only of those values. So this is if you want to style an output, this might be useful. Nicely formatted output. Define a function called report, takes one parameter wages. We can see here from the .keys method that its wages is designed to be a dictionary. Students is going to be the output of the keys method, so it's going to be a list of all the keys for the key value pairs in wages. Call the sort method to sort those alphabetically by the keys. And then for student in students, print %-20s. So that means 20 spaces after s, this student, the name, the key, percent 12.2, which means 12 leading spaces, or to the left, and then also a precision of 2 decimal spaces, that 0.2, F, so a floating point number. So we're doing wages, bracket, student. So that's going to be the value in the dictionary associated with this student. So for Mary, it's going to be her wage of 623.8, 23.8. For Joe, it's going to be 545. For John, 425. So call this report function passing wages. Going to take all of the keys out, sort them alphabetically. So we get Joe, then John, then Mary. It's going to print out the name of the student, 20 spaces, then 12 spaces, and their wage with a precision of 2 decimals. So Mary's 6.238 becomes 6.24. Now this format is Python 2. For Python 3, it's a bit different, and it makes use of a method called dot format. So that same exercise, the definition of a function, to pull out the keys in a dictionary, to sort them, and then to use a for loop to run through each. The base unit, you won't see any percent signs here. Instead, it gets replaced with curly brace, colon, curly brace. And those could have other characters in. So 20 is the trailing, and the alignment is signified by this less than sign, aligned to left. The 12 leading spaces, 0.2 precision. Here we go. And so that string, it's not followed by a space percent tuple. It's just got this dot format method called on it. And the parameters for that are going to be the leftmost insertion point, and then the second insertion point. So that's what you'd see in kind of later releases of Python 2, but also Python 3, is this dot format method.